Okay, so to find standard deviation of numbers, you'll very often see the process described as first we need to find the average of the numbers. And so on part A, that's probably kind of easy. If I add them all up, 3 plus 3, I mean, you can guess that it's 3 before we start, right? This is if all the numbers are 3, the average should probably be 3, but if I add them up, I get 12, and divide by there's 4 numbers, I end up with an average of 3. Or sometimes they'll use the mean, so this notation. All they're talking about is the average, so it's just a different, it's mu, the Greek letter, so they use for mean. So the average here is 3. So what we want to do in each step is say, okay, well, how far away from the average is each one of my data points? So I'll call all my data points x, or a bunch of x's. And then I want to say, okay, so for each one, how far is that from the mean? So I'll do x minus the mean on every single one. And then, just so I'm not doing too many steps at once, afterwards I'll square that, so each of those numbers, and at the end what I want is the average of all those squares, and what they refer to that as is the variance. And so to find the standard deviation, you want to take the square root of the variance. Basically, you're undoing the fact that you squared these all, and I'll show you on one that's more interesting. The reason you square them is because you don't want any negative numbers when you're taking this average. So then to find standard deviation, you want the square root of the variance. Okay, so on this one, all my data points are 3, the same numbers, kind of boring. And my average is 3, so when I do 3 minus 3, I get 0, 0, 0, 0 all the way down. And then when I square that, 0 squared is 0. So my average is 0. Right, if I add these up and divide by 4, so that means my variance is 0. And when I take the square root of that to get my standard deviation, then I also get 0. Okay, so let's stop and think about, that was a boring example, but what makes sense about this? Standard deviation is supposed to be a measure of spread of your data. So if all your data is the same number, then it makes sense to say that you have no spread. So they're not spread out at all. It's not a bunch of high test scores and low test scores. It's all the same number. And so if you have all the same number, your standard deviation should always be 0. Okay, so then let's try another one. So 0, 6, 6, 8. So first I need the average for those numbers, or the mean. So if I add that up, that gives me what, 20? This is 12 plus 8, and there's 4 numbers, so if I do 20 divided by 4, I get the average is 5. So now for each of these I want to do the number minus the average. So 0 minus 5 is negative 5, 6 minus 5 is 1, 6 minus 5 is 1, and 8 minus 5 is 3. So picture what these numbers are saying. This one is 5 below the average, because if you have a score of 0 and the average was 5, you're 5 below that. This one's 3 above the average, and these two are 1 above the average. Okay, so now I need to square all these numbers. So negative 5 squared makes it positive 25. 1 times 1 is 1, 1 squared, and 3 squared is 9. Okay, so now I need the average for those numbers. So 25 plus 1 plus 1, I'll just put plus 2 to save time, plus 9. Divided by, there's 4 numbers. So it looks like the average there is 9. So that means this has a variance of 9. And then since standard deviation is the square root of variance, my standard deviation is 3. And you'll sometimes see this symbol for standard deviation. So this one's 3, and the one we did earlier was 0. Okay, then we can try another one. So you won't have to do this with any that have very large data sets, because with not too many numbers, it's not as tedious, but it can get tedious kind of quick, so that's why they keep these pretty small. Alright, so in this one, I'll write down my data points, negative 6, 0, 0, and 18. So I can tell you already, before we start, I bet this is going to have a bigger standard deviation than this one, because it seems more spread out. I got a really low value, a really high value, and a couple in the middle. Okay, so my average, if I add these together, negative 6 plus 18 gives me 12, plus 0 plus 0. So 12 divided by 4 is a mean or an average of 3. So in all these, I want to do negative 6 minus 3, so I get negative 9. Picture what that means. Negative 6 is 9 below the mean. So if the mean is 3, go from 3 to 0 and then all the way down to negative 6. So that one's way below the mean. And then this one, 0 minus 3, gives you negative 3. So these ones are 3 below the mean. And then 18 minus 3 is 15. So this one's 15 above the mean. So the middle is 3. And this is saying how low above or below this is. Okay, so now I need to square these all. So negative 9 squared is 81. 3 squared is 9. All right, it's negative 3 times negative 3, so it always cancels the negative. And 15 times 15 is 225, I'm pretty sure. Double check over here. This is an example of like times when if you know something, it never hurts to check on it, especially if it's in the middle of a problem. You don't have to go back and fix steps from earlier. Okay, and then 9 and 9 is going to be 18, so I'll just add them together while I'm typing it in to save typing. So 324, because I want the average of these numbers, and there's 4 numbers. So it looks like their average is 81. So this has a variance of 81, but standard deviation is the square root of your variance, so it looks like standard deviation is 9. See how before we started I said that data seemed more spread out, so it would probably make sense that it would have a bigger standard deviation, and it turned out to. So just, it helps to have a table or something to organize since you have this kind of multi-step thing going on.